So we got u as negative cosine x, and then du as sine x dx. So here, what we're going to do is cosine squared x can be represented by u squared, which would be cosine squared x. So this would be u squared, and then equals u squared. But then we also have sine to the power of 2 and then x, right? So what we know from trigonometric identities is that sine squared x plus cosine squared x equals 1. So sine squared x equals 1 minus cosine squared x. So we can put sine into cosine in terms of cosine. So actually here it's a little complicated here now, but 2x times 1 minus cosine squared x, and then we also have sine x dx. So for this, now we can turn this all in terms of u. So since we have cosine 2x, we're going to put that as u to the power of 2, and then we also have 1 minus u to the power of 2, and then sine x dx, again, is just u. So we're going to put du integral. So that's our equivalent expression. So let's try to expand this out a little bit. U squared minus u to the 4th power is going to be the expanded version of this, and then du. So try to take the integral of this, which would be 2 plus 1 is 1/3, so reciprocal, or 3, so reciprocal of 3 is 1/3. 1/3 comes out, and then u to the 3rd power minus 4 plus 1 is 5, so reciprocal of that, 1/5, and then u to the 5th power plus c. But then the thing is, we know that u is actually negative cosine x, right? So we're going to say the answer is 1/3 times negative cosine x to the 3rd power minus 1/5 negative cosine x to the 5th power plus c. So this would be our answer. I know this is a little bit complicated. I'm going to get rid of some errors like it's complicated. We're going to simplify the situation a little bit. So it's going to be like this. Alright. And then that's the answer. Number 2 is going to be a little bit more complex. We're going to be using the technique of trigonometric substitution. Follow along. So integral of radical over square root of 36 minus 9x squared, and then all over x to the 2nd power dx. So for this one, you need to know the rules of trigonometric substitution. I'm just going to write it out on the side so that we don't forget, and then we can always refer back to this. So in the format of a squared minus x squared, we're going to use the substitution of x equals a sine theta, and then in the situation of a squared plus x squared, we're going to use the substitution of x equals a tangent theta. And then finally, in the situation of x squared minus a squared, we're going to use this substitution of a equals a secant, x equals a secant theta. So this is our trig substitution rules. I'm just going to highlight this out. How about I move this a little bit to the side? Okay. So now, in our situation right here, what do we see? We see a squared minus x squared format, right? Though it's a little bit different, so we need to kind of simplify things a little bit. So we're going to say inside the radical, we see that there's 36 and then 9, right? But then according to the format, there shouldn't be any coefficients in front of x. So we're going to change it. So we're going to factor out 9, which would be 4 minus x squared. And then that would be x squared over dx. And then since it's a radical, outside the radical, it would just be 3 times. We're going to put it outside the integral as well. 3 and then radical of 4 minus x squared over x squared dx. So we can see that we are fitting the format mentioned right here. And then a squared minus x squared. So a squared equals 4. A is just 2. Okay. So going back to trig substitution, x now equals a sine theta. So a is 2, so 2 sine theta would be our substitution. Alright, and then we're going to take the derivative of this to get dx, because we have to replace dx with something that's related to theta to match everything else that we're going to change in this situation. So this would be 2 cosine theta d theta. Don't forget the d theta, it's really important. Okay, and then we're going to go back and substitute everything back in terms of theta. So 3, and then radical 4 minus x squared would be x squared, or 4 sine squared theta, right? So we're going to put 4 sine squared theta right here, and then all over x squared again, which would be 4 sine squared theta. And then we're going to put dx, but in substitution of dx, we're going to put 2 cosine theta d theta. So this would be the complete equation in terms of theta. We're going to put the 2 in the front, so it's going to be 3 times 2, which is 6, and then cosine theta, and then right here, before we go further, we're going to try to simplify the radical a little bit. So we're going to factor out the 4, which means 4, and then 1 minus sine squared theta over 4 sine squared theta, and then d theta. So since there's a radical for 4, outside the radical, square root of 4 is 2, so it's going to be everything multiplied by 2, or 6 times 2 is 12, and then cosine theta. But then if you see right here, this again is an identity we used earlier. So same thing here, sine squared x plus cosine squared x equals 1. So 1 minus sine squared x equals cosine squared x. So right here it can be substituted by cosine squared theta. And then cosine squared theta. And we also have this, d theta, or 12 integral of square root of cosine squared theta is cosine, obviously. So we're going to multiply these two together. We're going to get this, sine squared theta, or the number goes out, so 3, and then square root of cotangent squared d theta. Okay, at this point we need to use another trigonometric identity. So one more that involves both cotangent and cosecant, because there's no way that we know a formula for cotangent squared theta integration, but we do know a formula for cosecant squared integration, right? So 1 plus cotangent squared theta equals cosecant squared theta. So since we know the known formula for integration of cosecant squared, we're going to put everything in terms of cosecant squared. So cotangent squared theta equals cosecant squared theta minus 1, right? So we can plug this back into the equation. So 3 integral of cosecant squared theta minus 1 d theta would be the proper integration substitution. And then 3 times the integral of cosecant squared would actually be negative cotangent theta minus theta plus c, which means negative 3 cotangent theta minus 3 theta plus c would be our answer.